So I'm not usually a fan of memorization of things, but unfortunately that's a good portion of this section. And it's really important for the year, but it's also something you'd be able to look up along the way. So in terms of needing to memorize it, you need to memorize it for the test. And you sort of need to memorize it for the year, but you can always look things up. So I'm kind of torn. Like I said, I'm not a fan of memorization. I just like when people learn how things work. But we're going to use these throughout the year. So what a parent function is it's the most basic version of a graph. And then we can possibly change it around, which are called transformations. So it's a different method of graphing. When you do graphing with parent functions and transformations, you don't make a table. A lot of people like this method because you don't have to do any work to be able to figure it out. It's all inside your head. This is the majority of the writing right here. On the test Thursday, probably Thursday. I say probably Thursday because if the printing comes back on time, we're having the test Thursday. If the printing comes back late, then it's Friday. So plan on Thursday. We're reviewing tomorrow. On the test, the third page of the test is 7 questions like this. And it's kind of a table. And the table has 3 columns: the name, the equation, and the picture. So you're going to be given one of the 3 pieces of information, and you'll have to write the other 2.
Like we'll be given quadratic, and then we have to write f of x equals x squared, right?
And then draw the picture.
Gotcha.
Yep. Or you might be given a picture, and then you'd have to give the name from the picture. Now I thought it might be helpful tomorrow if I gave you guys kind of a blank sheet and see if you, like, for you to kind of test yourself before the test itself. Be able to fill out a blank sheet with all this info. Because if you could do that, then you could list anything and everything. Flashcards might be a really good way for this one to, for you to learn this one if you need to. I guess it's kind of just depending on your own style of memorization, what works best for you. There's not many things in math that we have to just like memorize, but this is one. And obviously I don't care if you know how to spell it correctly. Now the first 3 you did quite a bit of in Algebra 1. I know when I taught Algebra 1, I tried to teach all of these at the same time so that you just start to know them. But I guess I have no idea who you had for Algebra 1, so. Did any of you have Mr. Sullivan for Algebra 1 2 years ago? I suppose half of you had the middle school one. Oh, I suppose 10th graders, you did it in middle school as well, because you guys had geometry last year. So only juniors would have taken it here. Okay. And if you can't read one of the words, like if it's too small, feel free to ask. I don't know if you can see the bottom ones okay?
Oh, yeah.
Okay. All right. So I'm guessing you're getting close to being done if you're not already done. The one thing you should notice about all these equations is that none of them have numbers being added or subtracted. They're all basically just a single x and then something on it. So whether, like linear is x to the first power, you don't write the 1. Quadratic x to the second, cubic x to the third. Square root has a square root symbol. Absolute value is just the absolute value symbol, and then reciprocal is just being divided by x. So these are called the parent functions because they're the most basic versions of the different, I shouldn't say shapes, but I mean that's basically what happens. Constant is the only one that's kind of weird. I had to draw it up on kind of off the axis because it's strange to think about it in the middle, I guess. But you'll see that I drew a red dot on each one of the 7 pictures. That red dot is what you're going to move when we transform them. So let me pick let's see if it'll let me pick it up, or is it going to be 2 pieces? Perfect. So let's say we're asked to transform the quadratic one. Wait, I almost forgot. I definitely get to use this first. Oh, it already fell out. That was lame. That didn't work right at all. Am I rolling the right way? Okay, I got, number 1, okay. Jaden. I haven't asked a question yet. You look pretty nervous. How would I know if you're being asked to graph a quadratic equation? What separates the quadratic equation up here than the other ones?
Use what's it called?
So like there wouldn't be a picture, there wouldn't be a name, you would just have an equation.
Yeah.
How would I know which one?
Because we're using the
Oh, you don't have to know the correct name for it, just,
next one.
yeah.
Yeah.
Yep, no, that's good. It has a squared on it. So if you see a squared, that means it's going to be a quadratic, and I know the picture is going to look like a U. And if, let's say I'm told to transform it 2 to the right, well then I would do is I would take that red point and I would move that red point, I guess I can't really, oh look at that. I would move that red point 2 to the right. And that red point is like the center of the picture. It's basically how you draw the picture, right? So what I do is I start from the center and I draw a curve going to the right, and then I draw a curve going to the left. I am not going to care what kind of a curve you draw, okay? I'm not going to grade you on how steep or wide your curves are, as long as your picture looks like a U. What I care about is that you're going to be able to learn a quadratic graph looks like a U shape, so it's called a parabola, but that doesn't matter. And then I'm going to check to see if you can do the transformation part correctly. That's really what I'm going to be looking for. And kind of the same thing for all of these. I just want to know that you have the correct shape. Does somebody have a question on one of these shapes that maybe you're not sure how it's drawn? Yeah. Oh, we haven't talked about that part yet. Yeah, I was just kind of prefacing it like to explain what we're going to do. Yeah.
How would you draw the reciprocal?
So the reciprocal, I don't know if you guys can see these dotted lines or not. These dotted lines are called asymptotes, and they're kind of like imaginary lines that your graph can't cross. So the reciprocal, you draw these curves that follow the dotted lines. So if you transform the reciprocal, you're going to, oh, perfect. You're going to move where it's centered, and then when you draw the curves, you're going to have the curves follow the new spot. So when you transform a reciprocal, you move to the middle of the two curves.
On the reciprocal, would it ever be like the curves are in the opposite spots? Like it would be.
Not this year, but yes, eventually yes. That's, what the heck?
Ooh.
If you ever have to flip something upside down, that's what would do it. Or it might be this year, but if not, not now. Okay, are we okay with all the rest of these shapes, like how they're created? Okay, here's the transformations. You only have to know two of them. You basically have to be able to move a picture up and down or left and right. Now, if you don't normally take notes, absolutely write this down because you're not going to remember it off the top of your head. Up and down is pretty easy to learn. Left and right is backwards, and so it usually confuses most people. But these are the only two transformations we're going to do. You know what I haven't figured out is a good place to put the little bingo ball when you're done. Because they kind of roll away. Oh. Maybe I'll have to make some sort of a stand where the cup attaches to it.
What are the chances you'll draw the same one twice?
0, because I took the ball out. That's why I kind of like this more than the dice, because the dice you won't get repeated. I mean, the dice ended up repeating a lot of times. This one you can't unless you put the ball back in. We're refining our system to be more mathematically perfect year after year for $15 at a time.
That was $15.
Yeah, I was really surprised it was that cheap.
That's a ripoff.
The other bingo rollers were like $80.
I have a good joke to tell you.
Well, because this is a ripoff? Wait, is the joke associated with the bingo roller?
No, it's supposed to be with a ripoff.
Oh, okay. Definitely don't tell it now because I'm recording.
Okay.
Okay, so the A and the B represent numbers. Neither one of them has to be there. Both of them could be there. All you're really looking for is if there is a number inside the parentheses, that means your picture is going to move left or right. If there is a number outside of the parentheses, your picture is going to move up and down. So let's say there was a +2 on the inside. Oh, wait, let me roll. $25. Cadence. If there was a +2 on the inside, what would that do to your picture?
You would move left too.
Left 2. Perfect. A plus number moves to the left. It's backwards from what it seems like it should be. And the more you understand these, then I can kind of explain it to you why it happens. But I'll wait until you guys learn them better first.
I think it's just like kind of like plus goes forward on the x-axis on a graph and minus goes backwards and that would.
Normally it does, correct, so it's backwards from that. Because plus moves it to the left.
Oh,
That's why it screws most people up, because plus feels like it should be to the right. Yep, very good. Okay, now, so here's the part that will definitely throw some of you off. Remember how I said if there's a number inside the parentheses? Well, if I go back to this page, none of them have a parentheses. So, let's say the quadratic one. If there is a parentheses there, the squared would be on the parentheses. But you don't put a parentheses if there's no numbers. Same with cubed. Sometimes there'll be a parentheses there, and if there is, then that number would mean left or right. And then the cubed would be on the parentheses. But if there's a number at the end, not inside of a parentheses, that's up or down.
Do you think you could maybe like,
Do some examples? Yep.
yeah.
Oh, I definitely have examples. I was trying to lay some groundwork ahead of time. Like this. Yep, I definitely have examples. We're only going to do a couple examples because I feel like you'll probably get it once you start seeing them. And then your homework's actually very short on this as well. Most of your homework is to memorize the 7. I know it's short notice. I just don't like any part about memorization. Some of you are very good at memorizing. I understand. Some of you are like me. Memorization was not one of my strengths. Whoa. Okay, this definitely doesn't work perfect. It just shot the ball out at me. 9. Munir. I don't know if you have this written down yet or not. Okay, I'll give you a minute. Feel free to get it written down first. Does anybody want to volunteer to write up on the board? Excellent. I'm feeling lazy today.
Just right now?
Yeah, people are going to tell you what to write. I've gotten it a lot of steps over the last week, so.
Do you want it red or green?
Oh, it's your choice. You're up there writing.
Mine's supercalifragilistic.
Although it would be pretty good if you can color coordinate. Okay, you ready, Munir? Which parent function would this one be from? Cubic. Nice. So next to the red one, write cubic. No, next to A. Cubic. Excellent. I suppose this is time to call on somebody else. 10. Hadley. What would be the transformation? Yeah, and you can use your notes. I mean, that's
Would it be right, like, 1 unit?
perfect. We're going to move it 1 to the right. So next to transformation, just put 1 right. Or right 1, whatever you want to, I guess, I don't know, what's the correct way of saying that?
Like, right 1 unit.
Yeah, whatever. All right. Yeah, we're in math. Come on. Okay, now we need to graph this. Do you want to just graph it? Do you feel like you know how to graph it?
Yeah.
Okay.
Something like that.
Yes. That is pretty horrendous, though.
Yeah.
That hurts. As a math teacher, that hurts to look at. Let's do this and pretend that didn't happen.
And
let's teach you the correct way to do it.
Okay.
Okay, so you did perfect
Mhm.
when you drew that.
Yeah.
So that's like the main focus.
Mhm.
Now, if we want a good looking S shape, do you
Ah,
upside down you.
okay.
You had the right idea,
Mhm.
but it's just painful. It's painful. Okay, questions from anybody on how to like approach this? Yeah, you're probably supposed to put arrows, but I'm not worried about those. Wait, why does everybody look like they're getting ready to go?
No, I dropped my pen.
Oh, okay, yeah, we got a lot of time left. 28? No. Yeah, 28. Today's a normal day. Okay, do you want to keep writing or do you want other? Oh, okay, excellent. You ready for the next example?
Yes.
Okay. X squared plus 2. What? There we go. 31. Aaron,
Oh,
what parent function would this graph be? You can use your notes. Get used to it.
quadratic.
Quadratic, nice. So the squared tells me it's going to be quadratic. It's a lot of rolling here. Seven. David, what would be the transformation on this one?
Gonna be 2 up.
2 up? I just didn't hear you.
I think it's 2 up.
Perfect. 2 up. Correct. So the plus 2 is at the very end. It's not inside of a parentheses. And when I say parentheses, that could be a grouping symbol, like a square root is a grouping symbol. So perfect. The plus 2 is 2 up. Do you think you could graph it?
I think so.
Let's pick the methods I showed you on the last one. Let's go from there. Good. Excellent. The point. Oh, nice. Look at that. This is like night and day from your first picture. Nice. Very nice. Okay, I have 2 more examples and then we're actually done. Are we doing okay on this so far? Questions on how to approach it? Okay? Square root of x plus 1. $14. Zena, what parent function would this one be from?
That one is square root.
Excellent. Square root. So you basically see the square root symbol, and that's the square root function. Did you write scroot?
Right. SQ for square and then just root.
I kind of like scroot. It reminds me of Groot. Yes, square root. Next person. It got stuck underneath. All right, so there's some flaws with this roller. 18. Bryce.
It goes 1 to the right.
Okay, how come? Oh, okay, which one?
It goes 1 to the left with the plus 1.
So because it's inside, it goes backwards. Nice. This one goes 1 to the left.
Wait, but there's
But it's
no
not
parentheses.
parentheses.
That's because a square root is a parenthesis. Like a square root symbol is a grouping symbol.
It's like inside it.
Yep. If the plus 1 was outside the square root symbol, that would be up and down. Maybe, you know what? This is a good time for me to go. Let me go back to the first page real quick. So a square root symbol is the same as a parentheses. An absolute value symbol is the same as a parenthesis. It acts like a parentheses. They're not obviously not the same. It acts like a parentheses. And on the reciprocal one, you're never going to see a parentheses because the plus and the minus numbers would be on the bottom of a fraction. The bottom of the fraction acts like a grouping symbol.
Oh, and then like for up and down, they just be on the side.
On the up and down would be at the very end, not part of the fraction. Right. So when I say parentheses, it just acts like a grouping symbol. Okay, graph. Do you know how to graph this one?
Yeah.
I mean, you're doing all these by memory, so this is pretty good.
Mm-hmm.
Good. Well, sort of good.
Not really.
Yeah, I mean, that one's a little wavy. That reminds me of like somebody's hair blowing in the wind or something. We'll go with it. I'll show you a trick. This is how you know when you can become a pro. If you want to hide your flaws, now you can't even tell that it's curvy. If you miss a line, you make your points bigger.
I can still see it.
No, you lie. You definitely lie. All right.
Because I have a vision impairment does not mean I cannot still see it.
Are we talking about the glasses? Because I have vision impairment too. In fact, a lot of us do. Okay, I did a bad job filling in the arrowhead. I'll do better next time. Okay, last question, and then we will be done. And this one is obviously different. You can sit down if you'd like. Oh, okay. All right, let's see. We have, oh, jeez, I did it again. 5. Haley. I'll give you a minute. If you want to write the info down. You probably didn't write anything down yet. So the first thing we need to do is graph this because we know nothing about it because it's just a bunch of numbers. Do you want to put those points on the graph?
These?
Yep. And then that'll tell us what it looks like and be able to figure out the parent function from it. Those go by 3s up and down, yeah. Oh, no, left and right goes by 1s. My fault. Yep. Yeah, -1, -2, 0, 2, 1, 7. Yeah, roughly there. Oh, I didn't even intend that.
Yeah, it's already here.
You know what? This is bad. This question actually came out worse than I thought. I wasn't even expecting this. So when I made up the table, I was actually trying to make a cubic one. But now that we've drawn it, it sure looks like a straight line. And that's because cubic and straight line could actually look the same if you only take a handful of points. So you wouldn't know if it curved unless you had numbers in between.
So like right here, it'd just be.
So like if we went at -2 and 2, then you would know if it was a straight line or a curve. So this one is your teacher's fault. Should we do a straight line? Because I don't think we've done a straight line one yet.
Or you could just say it's unsolvable because we don't have enough information.
Yeah, we're not doing that. I mean, you're not wrong. So the directions on this one, which I didn't write down for you guys, the directions for this question were to come up with the best estimate of a parent function and best estimate of a transformation. So, I mean, like what you're saying is correct too, but we're just trying to guess. So let's make this a straight line, just because. So let's connect them and make a straight line. Okay, good, nice. It looks like we planned that. I don't. Oh wait, I already rolled Haley, didn't I? Do you think you could help me decide which parent function this is, even though I might have said it out loud? Linear, excellent. So this is a linear parent function. And then the next person, okay, this is kind of stupid. My fingers are too big for this. 30, we don't have 36. We only have 31 in this hour. Oh, wait, is that right? Yeah. 16. Zach,
What was the question again?
I didn't ask one yet,
Oh, okay.
although it should be sort of obvious what the question's going to be.
What the
The only one we haven't answered.
transformation is?
Yes, perfect. What is the transformation? Oh, I forgot to write a question below it that we'll write next. Up, down, left, or right. Now this one's kind of unique because it actually could be two of them. And both of them would be correct.
I don't know.
On your notes,
Oh, right.
look at the linear picture. Where does linear normally, where is it centered, like the point?
The middle.
Okay, this one's not.
Oh, so we're gonna go down.
No, that was definitely not down.
Okay.
It doesn't cross through the middle, right? Where does it cross through?
Above the middle.
Yeah, so it went.
It went up.
That's it, right there.
Oh, it was where it went. Oh,
Yes, it went up.
I understand the
Yep.
question.
You were trying to say how to make it the original way. You were kind of answering opposite. Got it.
My bad.
Okay, so the transformation to me looks up too. What else could we have said that's still correct on this one, by the way?
To the right.
We could have said that it went left too. That still would have been correct. Because a straight line, you can't tell which direction it moved. So there's actually multiple correct answers for some of these. Now, the third question, which I forgot to write, would be, what would be the new equation? What would be our guess at an equation? So, EQ question mark.
What does that say?
It looks like Eli. Oh, Q.
Yeah.
You need a little hook, like a Q hook. Otherwise, it's a G. There we go. There we go. I mean, I'm not a good one to give lessons on handwriting because I just go fast. Does anybody think they know this one rather than me calling on somebody? Yes, ma'am.
I'm just taking a guess, but would it be f of x equals x plus 2?
Perfect. Absolutely perfect. F of x equals x plus 2. Okay, this is my fault that we didn't have as much time left as I thought. Mainly because I was talking too much, apparently. Here is your homework. The more you wrote on it, the worse it came out, yeah. Uh-oh, what happened? I don't want those icons. Can I just hit the right arrow? Perfect. Okay, your homework is only 6 questions.
Okay, but class is like literally over there.
Yeah. Yep. The main part of your homework is to learn the 7 parent functions. It sounded like a lot of you did a pretty good job already, though. Let me stop the recording because I'll forget.